Okay, everyone. So now we are going to make the second part of the program, that is prime number between 1 to n. We know that already we have made the first part, that is the Armstrong number up to n. So here the complete program, which is for Armstrong number up to n, we are going to hide it. That means we are making it a comment, so that first of all we make the prime number program. So we are putting slash, then star, that means everything is a comment. Now afterward we are going on the last, then we are mentioning that star and slash. That means this is part is a comment, compiler will not read that. Now here, first of all, we are going to make the program of prime number between 1 to n. So I'm going to make the program easy. That's why I'm making the program of simple prime number here. So for the simple prime number program, first of all, we are giving a message to the user that printf enter number. So user has to enter a number, and I'm providing the slash n before that, so that this should be into the next line. Then further, we need a scanf statement. So we are saying that scanf. Then afterward, %d for the integer value. Now here, we can use the same variable that we have used in the last program, part 1, that is num. But we can take the another one for the better understanding. So we are saying that, let's say, num1. So this is the another variable we are taking. So here, inside the num1, we are taking the number. So at the address of num1 variable, we are going to take the number from the user. We know that the number is a prime if it is divisible by itself or 1. So that's why we are making the loop. So for the loop, we are taking one more variable here for the better readability. So here j we are taking. So we are saying for j is equal to 2, because from the 1 it is already divisible. Then further, j less than n. So whatever the number which is entered by the user, that is num1. So that we are taking number 1. Then further, we are saying j plus plus. So this is the loop we have applied. Now inside the for loop, we are saying that if number, we know that number is num1. If num1 is divisible, that means we are dividing it with the j, and the remainder afterward is 0. So here we are assuming that this is a not prime number. So for the not prime number, we are mentioning here a flag. So we are taking a variable f here. Initially, we are assuming that flag is 1. So f is equal to 1, we are assuming. Now here at the end, we are mentioning that if flag variable equal to 1, that means we are saying that the number is prime. So we are mentioning printf prime. Otherwise, if the value of f got changed, then we are saying that printf not prime. Before that, we are providing the slash n, so that they should be coming to the next line. Now afterward, inside this number, if it is divisible by j, because the loop is going from 2 till 1 less than the number, so here we will make f equal to 0. That means number is no more a prime number, and break, because once we got that number is not prime, then we are breaking it. So we're going to execute, compile and run. So here we are having the output window. It is saying that enter number. So we are saying that let's say number is 7, enter. We can see that it is a prime number. Now we are understanding that how this program is working. So here we are executing the second part, which is the prime number. We are making a simple program here. So let us suppose that we are having a number 7. We know that number is a prime if it is divisible by itself or the 1. So 7 is divisible by 1 as well as 7. Now in between that, we are having 2, 3, 4, 5 and 6. Now that number is not divisible by any of them in between. So the 7 is the prime number. Now here we are having the logic. First of all, we are having a printf, means printing on the screen that slash n for the new line, enter number. So the user screen we are having a message, enter number. Now scanf means it is asking for the input. Now the cursor is waiting, so user has given that is 7. Now afterward, we have declared the variable that is num1. So the num1 variable we have already declared. So here the name is num1. Let's say the address is 301. Now inside that, we are having %d for the integer value, and num1. At the address of num1, we are taking the value given by the user. So 7 is going inside the num1. Now afterward we have taken a flag variable, so that f we have taken, so this is a variable f. So here we have declared a variable f here. Let us suppose that it is the address, that is 401, and the value of f we have given is 1. Now afterward we are having is a loop, so for j, so one more variable j is declared, so j is declared into the memory. Let us suppose that the address is 501. Now j is starting from 2, so here 2 we are starting. Now further, j less than num1, we know that num1 is 7, so 2 less than 7, perfect, fine, coming inside. Then if part, number 1 divide with j, so if I am dividing 7 with 2, then afterward we know that 2 3s are 6, then the remainder is 1. So here 1 is not equal to 0. So this is wrong. That means this part is not going to execute. Again it is going back, j plus plus. So the value of j will be 3. 3 less than 7, perfect, condition true, again coming inside. Now again 7 is divisible by 3, it is checking. So 3 2s are 6. Again remainder is 1. So here 1 not equal to 0. Again this part not work. Again going back. So again j plus plus. The value of j is 4. Similarly it is keep on checking. So for here checking 4 1s are 4. 3. Now 3 not equal to 0. So here false. This part will not work. Again going back. Again j will be incremented, so that is 5. Again checking the condition, is 5 less than 7? Yes, so the condition is true, coming inside. Again if is checking, so here again dividing with 5, 5 1s are 5, then 2, so here remainder is 2. 2 not equal to 0, so here this is wrong. Again this part will not work, again going back. So this is how j is keep on incrementing. Now further the value is 6. So again 7 will be divisible by 6. 6 1s are 6, remainder is 1. So again num mod 7, that means 1. Is 1 equal to 0? No. So this part is not working. Again going back. Further here j plus plus 7. 7 less than 7. Wrong. So here this condition is false. That means it is coming out. We can see that 7 is not divisible by 2, 3, 4, 5 and 6 successfully. So this loop was checking for that. Now here till the end we assume that flag was 1 and flag till remain 1. F is a variable. So that variable we are assuming like a flag. So f is 1, that means number is prime. So here number is prime. Let's assume that the number was, let's say 6. Now that 6 was divisible by 2 very first time. So here at that time flag will be 0 and then break will come here, it will come out and then not prime will come in that case. So here this is the simple program of prime number, but our task is not solved here. It is saying that between 1 to n, here we have checked a single number, that is 7. 7 is prime or not, but let's say user is saying 100. So from 1 to 100 we are checking what are the prime numbers. Let's say we are having a prime number, let's say 3, we are having 7, 11, so all the numbers we have to display. So we are going back to the code and modifying it. So here we know that we are having a program. So starting from printf and going till s, this is the complete program that is for the single prime number. So that complete program we have to put inside a loop, so that this loop should keep on continue. So first of all, this enter number we have to modify. So here we are saying enter value of n. So from the user we are asking this n. Now assuming that this n is the last value, so that last value we are taking inside the variable, let's say k. So I am taking that there should be a variable k. Now afterward we are putting everything inside the loop. So we are saying that for, then we are taking one more variable here, that is for running the loop. Let us suppose that L, so that is a variable. So we are saying that for L is equal to, L will start from 1, it is saying that from 1 to n. So we are saying 1, then afterward L less than equal to the number entered by the user, that is k. So this k, the loop will work. Then afterward we are saying L plus plus. So this is a loop we have provided. Inside the loop, we are going to put the complete prime number program. So here we know that this is the complete program of prime number. Right click, cut the program, and we are going to paste inside the for loop. So here we can see that this is the complete program of prime number. This is we has to modify also. We know that here we have taken num1 for the number. Now every time the value of L change, which is a loop starting from 1, 2, 3 up to the n, which is given by the user, that is k. So here we are providing that num1 will be equal to L here. So whenever the value of L is 1, number will be 1, 2, 2, 3, 4, 5, 6. So here for every number we are making a program for prime number. Now here we are printing only the prime numbers. We don't want the not prime number. So I am removing this part. Now afterward I am putting that prime number. And inside the prime number I am saying %d. So here in the %d I am putting a comma. So L. So every number we are going to check and see that it is a prime number or not. So this is how we have made the program of prime number. So this is from 1 to n. Now we are going to run this code. So execute, compile and run. Now here we can see that it is saying enter n. We know that n is the last value. Let us suppose that I am assuming the value is 20. So from 1 to 20 I want all the prime number. Press enter. So we can see that the code is saying 1, 2, 3, 5, 7, 11, 13, 17 and 19. These all are the prime numbers. Now we are understanding that how this code is working. So now we are understanding that how this code is working. We already know that this is the complete code that is for the prime number. So this code we want to repeat. So here we have made the value of n. So first of all we are saying printf /n enter n. Now on the user screen there is a message enter n. N is the last value. We know that. The second part is to find the prime number starting from 1 until the last value we are giving. Let's say user is giving is 20. So here we have declared one variable k. So first of all this variable k we are defining inside the memory. So that is variable k. Let's say the address is 301. Then further we are saying scanf means taking the input. So cursor is waiting. User has given the value that is 20. So %d for the integer value storing at the address of k. So at the address of k we are storing 20. That means from 1 to 20 we want to find what are the prime numbers. It is the input from the user. Then afterward we are making a loop. So for L, so there is a variable L we have declared. So one variable L we have declared. Let's say the address is 401 and the value is 1 right now. Then further we have L less than equal to k. So this one less than equal to 20 means from 1 to 20 we are finding. Right now the value of L is 1. Now afterward condition is true, it will come inside and we know that we have taken a variable num1. So num1 was the variable which was already taken and that num1 was the number. Let's say the number is at the address 501. We are taking that number is equal to L. So here the value of L is 1 right now. So now we are executing the complete code for the prime number. So here we are finding that whether this num1 that means 1 is prime or not. We know that 1 is divisible by itself and 1. So that means at the end flag will be 1 prime number %d. So here prime number is 1. Then afterward it is a loop. It will go back. Then afterward L will be incremented. So the value of L will be 2. Then condition check 2 less than 20. Perfect. Again come inside. Again num1 will equal to L. So here num1 will be 2. Again checking the prime number program. And we know that 2 is the prime number. So here this is how 2 is a prime number. Again going back. L will be incremented. That is 3. That is checking the condition. True. So num1 will be 3. Again checking. Yes. Prime number is 3. Again it will be 4. Num1 will be 4. So 4 is divisible by 2. So here it is not a prime number. It will not display it. Then afterward again going back. It will be 5. Then num1 will be 5. So here prime number is 5. This is how the L values keep on incrementing until the 20 is achieved. And num1 is also keep on having the value of L. So here the value will keep on incrementing until 20. We will display all the prime numbers, just like prime number 7, prime number 11, prime number 13, then 17 and 19. So all the prime numbers are displayed by this program. So this is how we have completed the second part, that is displaying the prime number from 1 to 20, or that means 20 is n. So from 1 to n is complete. Now we are going to modify this for the menu driven program. So we are going back to the code. So here we know that this is the menu driven program. We already know that the first part of Armstrong number up to n we have already made. So this is the comment, that's why this code is not taken by the compiler. Now inside that we are removing the comments. So star slash and initially slash star we are removing. Now this program is active. So inside that we are having the second option. That second option is prime number between 1 to n. So here this code we have already made. So we are going to select that complete code. Then we are going to right click, cut. So this code we have cut. We are removing the unnecessary space. Now further, afterward, we are having is the case 2. We know that second part is put into the case 2. So we are going inside the case 2, pressing enter, and here we are just pasting. So here we can see that we have successfully pasted the program of prime number from 1 to n. So here the case 2 we have made. So right now we have completed the two steps. The first step is Armstrong number up to n. So whenever the user is entering 1, so here this is the case 1 for the Armstrong number. Then afterward we are having is the second part, which is prime number between 1 to n. So whenever user press 2, so it will be going on the case 2. This is the prime number up to n.